for today. We're going to use the imaginary unit I to write complex numbers. We're going to add, subtract, and multiply complex numbers. Use complex conjugates to write the quotient of two complex numbers in standard form and find complex solutions of quadratic equations. All right. All right. I'm going to mute you for a second, Kenneth. Are you on campus?
Oh, I'm sorry. Yes, ma'am. I'm in
Yeah,
in the planning center.
I figured you were in near the cafeteria. All right, good. All right, consider the quadratic equation x squared plus 1 equals 0. We've encountered that before. Let's say I ask you to solve for x. What would you do first? Anybody? You can unmute,
Get
Kenneth,
x on
whenever
the
you.
side by itself.
How
Square.
do you
Subtract the one.
Subtract 1 from both
subtract 1?
sides.
Yep. Subtract 1 would be the first move. So let me do that. Subtract 1 from both sides like this. Make this bigger. All right. And so that's why they get this step right here. X squared equals -1. All right. But we haven't solved for x yet because it's x squared still. Then what would you have done
You have to
after
square
that?
each side.
Square root both sides, right?
Mm-hmm.
So you'll get something like this. And you end up with this. Now, they call I equals the square root of -1. Well, they call x equals the square root of -1, I. All right. So this is what I want you to memorize. They decided, okay, before we were like, oh, there's a negative number on the square root. We don't know what to do with that because we're in the real number system. Well, guess what? Now we're in the imaginary number system. And they define the square root of -1 as something called I. I standing for imaginary. All right. So I want you to memorize that I equals the square root of -1. Also note that if you square both sides, like so, if you square both sides, then I squared will equal -1. Does that make sense? If I equals the square root of -1, then I squared equals -1. Any questions so far? So I want you to memorize this. Let me write it over here. I equals the square root of -1. I squared equals what? -1. All right, because if you square a square root, remember the radical goes away. But we can even go further than that. Let's say I ask you, what is I cubed? We can use what we know about I and I squared. Would you agree that I cubed is the same thing as I squared times I? Is I cubed the
Yes.
same?
Yes.
Yes.
Yes. Right. Remember when you have the same base, you can add the exponents. So if we know that, then we know that I squared equals what again? What does I squared equal?
-1.
-1 times this I. Then that must mean that I cubed equals -I.
-1.
All right. We can go further than that. I to the 4th power, for example. How can you break up I to the 4th? Tell me a way that you can break down I to the 4th.
I squared,
I
I
square.
squared,
I square.
I squared times I
Square
squared.
times I squared. That's a good one because I squared equals what?
-1.
-1 times -1 equals
Positive one.
-1.
+1. We can go further than that if we want to. I to the 5th power. Give me a way to break down I to the 5th.
I squared times I squared times I.
Oh, I squared times I squared times another I. Okay. So that's -1 times -1 times I, which equals what?
1I.
I. Yep. Let's do one more. I to the 6th power. Give me one way to break up I to the 6th.
I squared.
I squared.
I squared times I squared. Okay. I squared times I squared times another I squared. So that's -1 times -1 times -1. Did we do that right? All right.
Mm,
What is that?
Positive I. Or I.
-1 times
it's
-1 times
-I.
another
Oh yeah,
negative.
that's negative. Yeah, I'm
What
looking
is
at it
it?
crazy.
-1 times
It'll
-1
probably
times
be
another
positive one.
-1.
No,
That's
it's a
negative
negative.
Huh?
one.
Negative one.
Negative
It's
Negative
three
one.
one.
negatives.
Negative
Yeah.
one.
It's a
Yeah.
negative.
Oh yeah, like -1 cubed. Yeah, -1. What I wanted you to notice is that we started out with I here. Then we said -1. Then we said -I. Then we said 1. Notice we started back over. I is the first one. -1 is the second one. What do you think would have came third? So I notice.
One.
Notice the pattern.
Negative
We started with I,
I.
-1, -I. It will go back to -I, 1. It's going to repeat over and over and over again. All right. I just want to show you that it's cyclical, as that it's like a cycle. It will repeat itself every fourth I. The same answer over and over again. So I'm put dot 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 because it keeps going on and on and on forever. All right. So I want you to see this little diagram. This huge circle right here is called the complex number system. Think of it like the universe. The complex number system is like the universe. We were over here on Earth. We've been dealing with the real number system all the way up to now. We were on Earth, and now guess what? We decided we were going to go to a whole nother planet and go over here to Jupiter somewhere, the imaginary number system. So all of it together is called a complex number system. We're just working with two different type of systems. All right. Some of it is similar, but some of it is new. So we're just going to have to learn the new rules for the imaginary number system. All right. I'm going to skip that because we already kind of did some pattern recognition already. All right. So we have this definition. A complex number is a combination of a real number and an imaginary number. The standard form, write this down. This is the standard form here, A plus BI. So this is the standard form of a complex number. There is a real part, that's the A, that's what's in blue. And there's an imaginary part, that's the B, that's attached to the I. So the number that's attached to the I is called the imaginary part. And we already know that I is equivalent to the square root of -1. Here are some examples of complex numbers that are in standard form. This one, 1 plus I, for example, or 39 plus 3I. All right. If I asked you, what is the real part of this one? What number would you say?
One.
One.
1. If I ask you, what is the imaginary part? What would you say?
Oh.
Okay.
Trick.
So it's 1I.
Which one? Yeah, it's a 1. Yep, it's a 1 in front. Consider to be a 1 in front of that I. All right, good. So here's some more examples in this little chart over here. Complex number, 3 plus 2i. The real part is 3. The imaginary part is 2. If you have a number 5, the real part is 5. B must be 0. Why? Because if you have A plus BI, then if you don't have the imaginary part, then B must be 0 if you don't see anything attached to the I. All right. So let's just say that was 5. A was 5, but B had to have been 0. All right. The next one, negative 6I. The real part that this time would have to have been 0, and the imaginary part is negative 6. All right, let's add and subtract complex numbers. To me, very similar to the real number system. It's basically, to me, like adding like terms. I don't really see the difference between this adding, subtracting imaginary numbers and adding, subtracting real numbers. So let me show you. 6 minus 4i plus 1 plus 3i is the same as 6 minus 4i. I'm gonna drop the parentheses because I don't need them in this case. What do you think we can add together? If I'm telling you, it's really no difference.
The
Yeah,
6 and the
6 and
1.
1.
Yeah.
6 plus 1 is
7.
7. And then what else?
The negative 4.
Negative 4i plus 3i.
3.
Which is
Negative 1.
negative I. All right. And I try for the most part write it as the real part first and then the imaginary part. Normally I write it like that. All right. I try. Sometimes I don't, but I try. All right, let's look at B. What would I warn you to be careful about with B?
You have a minus
The
1.
negative. The negative.
Yes,
Negative.
yes. Be on alert, because there's a subtraction symbol here. So let's write it out. We have 3 minus 2i minus, tell me what would you write next?
Parentheses 5
Negative
minus
5
4.
I plus 4I.
Plus. Very good. I wanted to see when you drop the parentheses, do you multiply negative through that parenthesis? All right. So now we have, well, I would say, sort of like terms. What could we add and subtract, or what are you
3
what do
minus
you
5.
consider? What is that?
3 minus
3
5.
minus 5,
Negative 2.
negative 2. And then
It'll be the 2 and the 4. Negative 2. So it'll be 2i plus 2i.
2i plus 2i. Good. It's simple as that. We're adding and subtracting. All right. All right. So C, again, 3 plus 2i minus 6 plus 13i. So I'm going to give you 60 seconds to work on that on your own. Work on that for a little while. Let's see if we get the right answer. Here you go. 3 plus 2i minus what? What did y'all write after the minus sign?
Minus
Minus
6.
6.
Minus
Yep.
13.
13.
Very nice. All right. Did we combine 3 and minus 6? What is that?
Negative 3.
Negative 3.
Negative 3. And then minus
Negative
11.
11i. All right. Very good. D. What operation is D? What operation?
Multiplication.
Multiplication. How do you know it's not addition or subtraction?
The parentheses.
Because we got the parentheses.
Parentheses are right next to each other. Nothing is in between these parentheses. So let's just FOIL it like we used to do with the real number system. It's only going to be a slight change in this, But for the most part, in the beginning, we do the same thing we normally do. 6 times 2 is
12.
12.
6 times negative 3i,
Negative 18i.
Negative 18. Yeah.
correct. Then negative 2 inside, negative 2i times 2,
Negative 4i.
negative 4i. And last, negative 2i times negative 3i,
6i squared.
6i squared. All right. We have sort of like like terms in the middle. Negative 18i minus 4i, combine it to get what?
Negative 22.
Negative 22i. But we also know that I squared equals what? Told y'all to memorize what I squared equals.
Negative 1.
Negative 1. So we got to break it down to negative 1. All right, so we have 12. Let me write it all out. So we have 12 minus 22i minus 6. So we're not done because we can combine 12 minus 6. What is that?
6 minus 22i.
Minus 22i. Yes. 6 minus 22i. All right, very good. Any questions about D? That was a little different. Anytime you see I squared, you have to convert it to negative 1. Anytime you see I squared, you have to convert it to negative 1. All right, let's look at E. Here's a question for you. We have 3 plus 2i, and we have 3 minus 2i. What are those called? These 3 plus 2i and 3 minus 2i are called. Give me your best guess. Best guess. My other class didn't get it. My other class didn't get it. Let's see if y'all get it. What are your guesses? Alicia, what did you say?
The difference and so on.
You know what? They said something similar to that. That's not what I'm looking for. The word I'm
Is it
looking
that they
for.
just cancel out?
Honestly, I just brought it up last week. So
Conjugate.
Nakiria, what did you say?
Conjugate.
Conjugates. All right. Conjugates. They are conjugates. All right. And if you look at the notes previous and prior to me doing this, you'll see on the next page it says conjugates. All right. So anytime you have conjugates, that's nice. When you multiply conjugates together, something nice happens. Let's work it all out so you can see what happens. All right, let's 3 times 3.
9.
All right. 3 times negative 2i.
Negative 6i.
All right. And then inner, we got 2i times 3.
6i.
Yep. And then 2i times negative 2i.
Negative 4i.
Negative 4.
I squared.
I squared.
I squared. Just like x times x. All right. What's nice about it is the middles cancel. Sort of like what you kind of alluded to difference of squares, right? So I get what you were saying. So that's 9 minus 4 times what?
Negative 1.
Negative 1. Every time we have I squared, we got to convert it to a negative 1. So really what we have is 9 plus 4, which equals
13.
13.
13. So here's what's nice about multiplying conjugates. Multiplying conjugates. You won't end up with an I in your answer. Notice that. You only end up with a real number. So whenever you multiply conjugates together, you only end up with a real number, not an I. So we're going to use that to our advantage in the next section. So that's why I set it up like that. All right, complex conjugates are a pair of complex numbers of the form a plus bi and a minus bi, where a and b are real numbers. conjugates. A conjugate is where we change the sign in the middle, like this. So the only sign you're changing is the one in the middle. All right. So you kind of used to this with radicals. Remember we talked about conjugates last week when I said if, for example, 2i is a zero of some polynomial, then negative 2i is automatically a zero of the polynomial. It just, they come in pairs. For whatever reason, they both work. All right, let's look at this next one. 3i over 2 plus 4i. Remember when you had radicals in the denominator, what was the rule? If your answer had a radical in the denominator, what's the
You're
rule?
just gonna use greater than or
Interchange.
equal to.
Yup. We had to get the radical out of the denominator by
Go
multiplying
multiply
it by what?
the radical on the top and the bottom.
Yeah, what type of radical? Would it have been the same thing?
Oh, yes, I think.
The conjugate, actually.
Oh.
So you've been doing this for a minute and not realizing you've been multiplying by the conjugate. So this same rule applies with imaginary numbers. There's a rule. You can't have i's in the denominator either. All right. So guess how we're going to get that I out of the denominator?
Multiply the
Multiply
top
by
and the bottom.
negative 4i.
Multiplied by the conjugate, which is what again?
Negative 4i.
2 plus 4. 2 minus
2,
4i.
2 minus 4i. All right. So again, conjugates. A plus bi, a minus bi are called conjugates. So from this example right here, we learn when we multiply conjugates times each other, we don't have an I. So we're going to use that to our advantage and get that I out of the denominator by multiplying the denominator by its conjugate. All right. I don't know how my little line ended up over here. All right, here we go. So let's focus on the denominator first, since that's what we're trying to work out. We're trying to get that I out of the denominator. So let's multiply. 2 times 2.
4.
All right. 2 times negative 4i.
Negative 8i.
Yep. 4i times 2.
8i.
Plus 8i.
Yep. And 4i times negative 4i.
Negative 4i squared, so just 4.
Negative. Say it again.
Oh, 16. Sorry.
16i squared.
16i squared. All right. Let's go to the numerator now. We'll come back for the denominator. What is 3i times 2?
6i.
Yep. 3i times negative 4i.
Negative 12i squared.
Negative 12i squared. All right. We obviously got a lot to do because I squareds popped up. And what else can we do in the denominator?
You can cancel out the 8.
Yeah, let's please get rid of all that. That's in the way. So we have 6i in the numerator minus 12 times what number?
Negative 1.
Negative 1. Nice. Over 4 minus 16 times another negative 1. So I'm going to flip this 12 in the front. So in the numerator, we have a 12 plus 6i over what number so far? What's in the
4 plus
denominator?
16 is
4
20.
plus 16, which is 20. All right. Since we want it in the A plus BI form, we're going to split it up. This is the same as 12 over 20 plus 6i over 20. So we want to separate our real part from our imaginary part. All right. So we're going to reduce 12 and 20. How can we reduce 12 over 20?
By 4.
4. Okay.
No,
4 can go into 12 how many times?
4 over 5. You going there 3 times.
All right, 3 times. And 20, 4 can go in
5.
20 5 times.
So 3 over
Right.
5. Yeah.
So that's 3 over 5 plus, what about 6 over 20? What number can go in both 6 and 20?
2.
2. So that's a 2 goes into 6 how many times?
3 times.
And 20?
10.
All right. So we have 3 over 10. You can put the little I to the side of it, or you can, if you want to put 3I over 10, it means the same thing. All right. So this is the standard called the standard form, where it's split up. And we'll try for the most part to write our answer like that. All right, let's look at B. We still have an I in the denominator. Someone other than Alicia, Kenneth, Nakiria, Zoe, and I don't know who else been talking a lot. Other than people who have been talking a lot, what are we multiplying the numerator and denominator by? All right.
1 minus 2i.
1 plus 2i.
What's the conjugate of 1
1.
1
minus
plus 2i.
1 plus 2i? So we're going to multiply top and bottom by 1 plus 2i. Because if we multiply by the same thing, it's not going to cancel the middle part. All right, 1 plus 2i. 1 plus 2i. So if we multiply the denominator by something, we have to multiply the numerator by the same thing, or else we just change the entire problem. So we have to do the same thing top and bottom. All right. Let's focus on the denominator. 1 times 1.
1.
1. 1 times 2i.
2i.
2i. Negative 2i times 1.
Negative 2i.
Yep. Negative 2i times 2i.
Negative 4i squared.
Correct. So y'all, maybe y'all haven't noticed it yet, but anytime we're multiplying conjugates together, y'all notice the middles cancel out.
Mm-hmm.
So honestly, you don't even have to multiply, do the whole 4, to be honest. You could just do the first and the last part of 4. You don't have to do the inner side of it. All right, that's just a little tip. But if you're a little shaky on that, foil the whole thing out. All right, let's look at the numerator. These are not conjugates, so we have to do foil on the numerator. All right, we have 6 times 1. What is that?
6.
6.
All right, 6. 6 times 2i.
12i.
12i.
Yep. 7, negative 7i times 1.
Negative
Negative
7i.
7i.
All right, and negative 7i times 2i.
Negative 14i
Negative
squared.
14i.
Very good. I squared. Negative 14i squared. All right. Hopefully y'all got this over here. I'm going to erase it. It's in my way. All right. I want you to write down what you think the next step is before I write the next step. All right. So I'm going to give you 60 seconds to work on the next step. So write what you think should go here. All right. We have 6. Did you all go ahead and combine your like terms or not? Yes.
Yes, ma'am.
What
5i.
did you get? 5i. All right. 5i. Then
Minus
also minus 14 times
negative 1.
negative 1. all right, over 1 minus 4 times
-1.
-1 again. All right, I'm going to give you 60 seconds to write down the next step. All right, you might have to unmute since I muted y'all. All right, now did you write 6 plus 5i plus 14
Yes.
over 1 plus 4, which is, tell me what's in the numerator now.
20 plus 5i over 5.
Very nice. 20 plus 5 over 5i over 5. And then we want it in standard form, so we're going to split it up as how? How should we split it up?
20 over 20 5. over 5.
5 over 5.
Very nice. That reduces nicely. 20 over 5 equals
4. 4.
4 plus
I.
I, because the 5's cancel out. 4 plus I is the final answer. Any questions about B? Any questions about B? Nobody? Okay. All right, let's practice a little bit more before we move on to the next part of this lesson. We're going to practice here. Multiply each complex number by its complex conjugate. Let's just practice. Make sure you got it. What is the complex conjugate of 1 plus I?
1 minus I.
1 minus I. Thank you. 1 minus I. Again, the conjugate is where we change the sign in the middle. All right, so 1 minus I. So here's what we're going to do. We're just going to multiply that by 1 minus I. So I'm going to give you 60 seconds to work it out. All right, when you're finished, direct message me your answer. I want to see how many of you got it right. Direct message me. So don't send it to everyone. Find my name and only send me the answer. Only send me the answer, not everyone. Okay, Monisha, that's right. All right, Justin, that's right. Okay, Kenna. All right, Sophia two's like 2 question mark. All right, let me go ahead and tell you it is 2. All right, so again, I know these are complex conjugates, so I know the middles will cancel out. So I'm gonna do my little shortcut. I'm just gonna multiply 1 times 1 together. All right, what does that give you? 1 times 1, what is that?
1.
1. And I'm gonna multiply I times I, negative I together. What is I times negative I?
Negative I squared.
Negative.
Negative I
Yeah.
squared, right? But we know that I squared equals what?
Negative 1.
Negative 1.
1, which means that's a 1 plus 1, which equals 2.
2.
You see it? All right. That negative, two negatives in the middle would change to a positive plus 1. All right, let's try this again. B. All right. Other than whoever answered before, what is the complex conjugate of 4 minus 3i?
4 plus
4 plus
3i.
3i.
4 plus 3i. All we're doing to find the conjugate is changing the sign in the middle or the sign in front of the imaginary part. All right. So I'm going to erase this. Hopefully you got A. I want you to multiply 4 minus 3i times 4 plus 3i. And when you're done, I want you to direct message me the answer. Okay, Manisha, you are on it today. Yes. Yes, Christina. Yes, Ashley. Yes, Kenneth. Yes, Nakiria. Very good. All right, I'll give you about 10 more seconds just in case you want to finish it. All right, Tanaya. All right, so again, you can FOIL all of it out if you want to. No problem. I just know, because we know the rule, right? That when you multiply conjugates together, the middles will cancel out, sort of like difference of squares. All right, so 4 times 4, though, I know the little trick to it. So 4 times 4 is 16. And I know that negative 3i times positive 3i is negative 9i squared. We're going to change the I squared to a negative 1, which will make this 16 plus 9, which equals 25. So if you got 25, very good. All right, I think we're good on that. Let's learn something else about the imaginary number system. It turns out, let's go over here in this box. It turns out that the square root of negative 2 times the square root of negative 3 is not this right here. This is what we're used to for the real number system. In the imaginary number system, you can't do that. If you have negatives under the radical, you have to follow this process up here. All right. So we're going to convert some radicals to i's, and I'm going to show you how to do that. So let's go over here to the left. All right. So they're saying that the square root of negative r equals I times the square root of r. How is that? Well, let me break it down for you. The square root of negative r, is that the same as the square root of negative 1 times r? Would you agree? Yes or no?
No.
Yes.
Yeah, right. Isn't negative 1 times r negative r?
Yes.
It is, right?
Yes.
Same thing. All right. Now, we learned in algebra class that you can split up a radical like this. Can we split it up? If we have one square root, we can split it up into 2 radicals, or we can split up in as many radicals as we want, to be honest with you. All right. Now we know that the square root of -1 is the same thing as what?
I.
I. All right. Just I, right? So make sure you go back to page 1 again. Make sure you memorize these two. I equals the square root of -1, but I squared equals -1. All right. By the time you finish this section's homework, you will remember. All right. So we have I times the square root of R, which is just I times the square root of R. All right. So that's how they got this I times the square root of R business over here. All right. That's all that means. All right. So let's start with A. We're going to take it slow. Square root of -1 is what again? Let's practice. What is the square root of -1? The same thing as?
I.
I.
I. All right. I'm going to ask you that about 10 times before I let y'all go today. All right. So yes, I. All right. Next, we have B, the square root of -16. We can rewrite this radical as -1 times 16. The square root of -1 times 16. Isn't that true? Isn't that the same thing?
Yes.
Yes. Then we learn in algebra class that you can split up radicals like this. The square root of -1 times the square root of 16. All right. What is the square root of -1?
I.
I. I. And the square root of 16?
4.
4. So the answer is 4I. All right. It'll be awkward to keep the 4 second. Need to put, that's sort of like our coefficient. So we put it first. All right. Let's try another one. Sometimes you're going to write them a little different. It's okay. The square root of -3, for example. Tell me, how can we rewrite this radical? Square root of what times what?
Square root of -1 times square root of 3.
All right. All right. I always like to see the -1. So that's going to see me put that -1 separate. All right. Here we go. Square root of -1 is what?
I.
Y'all gonna get tired of me asking that. Now, 3. Is 3 a perfect square?
No.
Oh, man.
No. So we cannot break down the square root of 3 anymore. So it's I times the square root of 3. And yes, this is the same thing as the square root of 3I. But here's the problem. In Weber sign, I don't know if y'all done radicals yet, but have y'all noticed when y'all put a square root or a radical and it'll just keep going on like that?
Mm-hmm.
That's not the same thing. This is not the same. All right. The I does not supposed to be under the radical. So I would recommend for something like this, see if website will accept this. Y'all have to let me know Thursday. Would they just
I
accept?
did it, Dr. Thomas. You have to hit the space button and put the I on the
Mhm.
outside.
Yep. You're gonna have to hit the space bar or arrow, the down arrow key or something, so that it'll stop going, continuing on and on forever. All right. That I should not be under the square root symbol. It's separate from square root of 3. All right. So again, let me say that one more time. That I should not be under the square root symbol. So however you do it, I'm okay if you write it like this, is what if WebAssign would accept that. So that's why you probably will see me put I's in front of radicals, so that you will know that it's not supposed to be under that square root symbol. All right, let's look at D, the square root of -8. Let's see how we can break that down. Square root of, we know it's -1. I always want to see that -1 basically, well, how would I say it? Separated from the other numbers. So -1 times. Now, 8. Is 8 a perfect square though? Is 8 a perfect square?
No.
No, it's not. No, it's not. However, there's a rule in the real number system that talks about perfect square factors. We can't keep perfect square factors under the radical. So does 8 contain a perfect square factor?
Yes.
Yeah, 4.
4. Very nice. 4 times 2. So let's split it up into 3 radicals this time. We have the square root of -1 times the square root of 4 times the square root of 2. All right. Let's look at the square root of -1. What does it equal?
I.
I times, what's the square root of 4? What does it equal?
2.
2 times the square root of 2, since 2 is not a perfect square. So the answer, final answer, you can write it as 2i times the square root of 2 if you want to. I've seen it like that. 2i times the square root of 2. All right. All right, so the next little part, write the complex number in standard form. Well, we'll try our best. 1, nothing's wrong with 1. We're going to write it back down. Plus, we just did the square root of -8. We said it equals to 2i times the square root of 2. So that's, I know it could be written like this. I just don't write it like this. Again, I don't want that I to kind of sneak under that radical. All right. So that's why I write
Yeah.
it as 2i times the square root of 2. But they are the same if you realize that the I is not under the radical.
I was gonna say I feel like that's very misleading, Dr. Thomas.
What's misleading?
The I being behind the radical two.
Yeah, yeah, yeah. But I did it that way because they say the standard form is BI. See how the B is in front of the I? So the number's supposed to be in front. But I'm perfectly fine with you writing it this way. 1 plus 2i times the square root of 2. All right, let's look at this. It turns out that the square root of -2 times the square root of -3 equals I times the square root of 2. All right, times I times the square root of 3. Well, we know that the square root of -2 is the square root of -1 times 2, which is this, I times the square root of 2. We know that the square root of -3 is the square root of -1 times 3, which is I times the square root of 3. Then they multiplied the I times the I together to get what?
I squared.
I squared. Then they multiplied, now that we got the negatives out of the radical, you can now multiply the 2 times the 3 together to get what?
6.
6. They converted I squared to what?
-6. I mean -1.
-1. And -1 times the square root of 6 gives you this answer. So, what's the point of all that? The point is, if you have negative numbers on the radicals, we cannot do it this way. And we can't do it that way. In the imaginary number system, you have to convert everything to i's first and then express them. Well, first express it in this form for with i's and then simplify your answer. You can't just multiply what's under the radical times each other if there are negative numbers under the radical. So that is a different rule with the imaginary number system that is really different from the real number system. If these numbers were positive, we could just multiply what's under the radical times each other. But with them being negative, we have to convert them to imaginary numbers first and then simplify. So let's practice. We have the square root of -6. All right. Let's break down the square root of -6. How? How do we break up the square root of -6?
Negative 1.
-1 times
6.
6.
6. And then the square root of -2 is same thing as?
Negative 1 times 2.
Yep. And if you want to, you can break all of these radicals up like so. Once you get the hang of it, you don't have to do this over and over again. You can kind of just write your I down. But for now, we're in our learning stage. We're going to write everything down. All right. Square root of -1 is? I. We got I square root of 6. We got another I times the square root of 2. All right, let's go over here. I'm running out of space. What can we multiply together at this point?
The i's.
Yep. Yep. What is I times I?
I squared.
I squared. What else can we multiply together?
The 6 and the 2.
Radicals.
Square root of 6 times the square root of 2. What does that equal?
Square root of 12.
Square root of 12. Something happened there though. What happened that we have to work with right now? Square root of 2. Well, I squared equals what?
-1.
-1.
But something else happened with this. What happened?
You gotta get the perfect square out of the 12.
Very good. A perfect square popped up when we multiply 6 times 2. It basically created a perfect square situation. So we have to write it as 4 times 3, which is -1 times the square root of 4 times the square root of 3. What is the final answer? I know. Let's write it out. Let's write it out. We got -1. Let's take our time. -1 times, what's the square root of 4?
2.
2. And we cannot break down the square root of 3 because 3 is not a perfect square. So what we really have is -1 times 2, which is?
-2. Oh, yeah, 2. Yeah. Oh, wait.
-2, you right?
Okay, okay.
All right. -2, right? -1 times 2 is -2 times the square root of 3. All right. Again, I is the square root of -1, not -1. I is the square root of -1. All right. Last page. Complex solutions of a quadratic equation. We have solved a equals x squared plus 4 equals 0. Let's try this again. We kind of alluded to it earlier, but if we were solving for x, what would we do first for x squared plus 4 equals 0?
Subtract 4 on both sides.
Very nice. Subtract 4 from both sides. That's how we get this step. X squared equals -4. But we haven't solved for x just yet because it's x squared. What will be the next step?
You square both sides.
Got square rooted. Yeah.
Square rooted. That's how you're going to get the x equals plus minus. But let's break down -4. How could we rewrite the radical?
-1 and then
Yep.
4.
Yep. -1 times 4, which equals plus or minus the square root of -1 times the square root of 4, which y'all see is plus or minus 2i. All right. quadratic equations. What are the degree? What is the degree for a quadratic equation?
Squared.
All right. How many solutions should we get normally with a
2.
quadratic
2.
equation? Because the degree is 2, we should get 2 solutions. All right, let's try this one. 3x squared minus 2x plus 5 equals 0. Where should we begin to solve this quadratic equation?
Subtract
Minus
5.
5. Minus first.
Both sides.
All right, let's go over this again. Whenever you have a degree higher than 1, we can't use those linear equation methods any longer. There are other
Oh,
methods.
you got a factor.
Okay, very good. One way is to factor. So let's see if we could factor first. How would you even approach this? What was the first step if you said, I wonder if it's factorable? What would you do first to figure out if it's factorable?
A times C.
Yep, you would do A times C. What is A times C? Someone other than Alicia.
15.
15. Then we write all our factors out. 1 and 15. What else we got?
3 and 5.
3 and 5. Will it work? Will it work? Where will we have to put negatives at and all that at? Y'all see it would not work. Y'all see that? It would not work. Why wouldn't it work? Anybody can explain to me why it's not factorable?
Because you don't have nothing that's going to equal the middle, the -2.
Well, 3 minus 5 is negative 2, right?
It's the 5. The -5 and -3 ain't gonna. A +3 ain't gonna equal a +5. Oh, you want if you multiply
Say,
like the
okay.
3 and
But
the
when you
I
5,
add the
uh-huh. It's not gonna give us what?
5, a positive
5,
5.
yeah.
It's not gonna give us positive what? Okay, why does it? Okay, y'all, we pre-cal, y'all advance. Why can't we factor this? Why doesn't this work? 3 and -5. You might a
Because
smart
it
group.
won't
Come on.
add up to get 5.
Why are we looking for 5 though? Our middle
Because
number is
that's
-2. All right. Anybody see why we
It'll be
can't
a
factor?
-15, yeah, when you
Thank
factor
you.
3.
Thank
Yeah.
you. Thank you, Kenneth. 3 times -5 would not give us positive 15. That's why. If it was negative AC, negative 15, then it would have worked. All right, but it doesn't. Now that we realize the factoring method is not going to work out, what's another method, someone other than Kenneth,
The
that we can
quadratic
use?
formula.
Thank you, Nakiria. Quadratic formula. Someone other than Kenneth and Nakiria. What is the quadratic formula without you all looking back at the quadratic formula?
-b plus minus.
Nakiria. No, Nakiria, not you, not you. What is the quadratic formula? Remember I had y'all to memorize it and all for the first quiz? Anybody still held on to it? Oh, no. Okay.
I
X
think I
equals,
know it.
okay, what is it?
X is equal to -b plus
Mm-hmm.
minus the
Yeah.
square root b squared minus 4ac over 2a.
Yes.
That's right.
All right. There was a song for it and everything. Stories about it. Maybe I didn't tell y'all the story about the quadratic formula. Y'all remind me next time to tell y'all the story about the quadratic formula. Maybe we can remember it. All right. Let's look at B, because I think we only have time for Now we'll see. We might have time for both of them. Let's identify what A is, B is, and C is. What is A?
3.
3.
Yes. B equals,
-2.
-2.
and C equals,
5.
5.
very nice. So when we plug it in, we have X equals negative what? What are we plugging in for B?
-2.
-2. Well,
Negative 2. So um I want you to kind of write it all out first. And then you can, on that second step, y'all can simplify. Plus or minus something squared. What goes in the parentheses?
-2.
-2.
-2 again. Square minus 4 times what times what?
Times
3
3.
and 5.
All right. 4 times A, which is 3, and he says C is 5. All over 2 times what?
3.
All right, 3. All right, this thing's, my color's not changing over here. 3, 3, 5. All right, this is a step where I want you to simplify. So we have X equals, what is a negative of a -2?
2, +2.
Positive 2 plus or minus the square root of -2 squared.
4.
4 minus what number? 4 times 3 times 5.
-60.
60. Very nice. All over what number?
6.
6. X equals 2 plus or minus the square root of, we got to put what is 4 minus 60?
-56.
-56. All over 6. Are we done?
No.
No.
Nope. What is one thing you see we definitely got to get rid of under this radical?
Negative under
The
the
negative.
Definitely negative. Anything else you see under this radical that we got to get rid of?
the perfect square.
There is a perfect square in 56. So there's a rule. If our number contains a perfect square factor, we have to get it out of there. So what is the perfect square factor? In 56. So that's when you take your perfect squares and you calculate and you divide 56 by 4, 56 by 9, 56 by 16, 56 by 25. Which one of these perfect squares can divide into 56?
2.
4.
4. All right. 2 is not a perfect square. So what are the perfect squares? Starting with 1. So maybe we need to review this. 1. What's the next perfect square?
4.
4. What's the next perfect square?
9.
9. What's the next one?
9.
16.
16. Next.
25.
25.
Next.
36.
All right. So all we're doing is 1 square, 2 square, 3 square, 4 square, 5 square, 6 square, and so on, which is why they're called perfect squares. All right. Now we have X equals 2 plus or minus. Let's split up our radical into 3 radicals. Square root of -1 times the square root of 4 times the square root of 14, all over 6. All right, let's begin with the square root of -1. What is it? What is the square root of -1? I. Next, what is the square root of 4?
2.
2.
2. Is 14 a perfect square?
No.
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 Nope. It's not on our little perfect square list we just wrote. So nope. So what we have is 2 plus or minus 2i times the square root of 14 over 6. But guess what? We're going to split it up because I want it in the a plus bi form. So x equals, we got 2 over 6 plus or minus 2i over 6 times the square root of 14. So which means it reduces to what? What is 2 over 6?
3. No.
Is it?
1/3.
1/3. 1/3, since that the lower number is in the numerator. Plus or minus, and then you can put 1/3 again if you want, times I times the square root of 14. There's a lot of different ways you could probably write that, but that's one of the ways you can write it. All right.